to be able to handle it?
I'm not ready.
Well, that's true, but
Primary,
all right.
like red or yellow.
So 1A, I wrote this down, and then I did this, so I left the 2 out. Does everybody understand how I got what I got here? No, I don't like that answer.
Wait, is this a practice test?
Yeah.
There's a 2 in front of the code.
I know. I'm just saying what I wrote on the answer key.
Oh, wait.
Because I took math 128 last semester and we learned the new.
We're not there yet.
Okay, so you want us to just divide it like do the opposite, divide it by the.
So antiderivative means undo what the derivative was done, right? So if the derivative is cosine, it must have come from sine. You with me?
Yeah.
And the way I wrote it down, if there's a 2 there, then that's great. Because if I take the derivative of sine of 2x, I would get cosine 2x times 2. You guys see what I'm saying?
Yes.
I mean, alright, so let's start fundamentals. If you know derivatives of functions, you know how to underderive a lot of them.
Yeah.
Right? It's really easy for me to make it that you can't. They have to be really nice, to be honest. So the way to attack a problem like this is to say, I know it had to come from a sine. So it had to come from a sine. But if I just write this, then I could check. You know, I always got that plus c. To check, you take the derivative, and sure enough, it would be cosine 2x times 2. There you got everything you need, right? So the way I wrote it down is a little more interesting. If that 2's not there, and you say, okay, I know it had to come from a sine. Let me check and see if that looks right so far. And if I need to adjust it, if I took this guy's derivative, I would get cosine 2x times 2. If there was no 2 there, then I would have to... This wants to have a 2 show up, right?
Yeah.
Therefore, I have to divide it by 2, so that 2 that comes out would die immediately. So that's the... Before you learn the U thing, which we will learn, we're doing, pure calculus, not 178 dribble down calculus. So we'll get there eventually. But this I don't need to use sub 4. It's like one step away from a pure derivative. Yeah.
Number first one C, I think 2 is missing. So in your answer, because I think it should be 2 tangent x cubed minus 2 plus c.
Yeah, I'm missing a 2, right? Yeah, cool. So I had trouble with 2 on this first round for some reason. So think about this. If I had, alright, so the f prime I'm giving you is this. Oh yeah, that's right. I did this that morning that I was not feeling the best, but oh well. I won't take any excuses. This is my mistake. If I look at this part, I know it had to come from tangent. Alright, I know it would have to come from this, right? I'm not going to stop here. I'm just going to look. If I did the derivative of this, I would get secant squared this times the derivative of this.
Yeah.
And what's the derivative of this?
3x squared.
3x squared. So, and this is 6x squared, so there should be a 2 there. I like it. I mean, do you guys see what I'm saying, though? Secant squared had to come from tangent, right? It had to, because that's how you get... What do you take the derivative of to get to secant squared? Tangent. I like it. So it had to come from tangent of this, because the inside of a function does not change when you take derivatives, right? So it had to come from a tangent of this. But when I take this guy's derivative, I would get secant squared of that times 3x squared. But there's a 6x squared there. So just put a 2, because it doubles what would come out. I like it. So there should be a 2 in front of that. I like it. Kick ass. But what's important there is the process. How do you even start? You focus on what the actual function is, and then you worry about any weirdness that's inside of it. So the quick way to make this totally undoable is to say, okay, now do this one. Yeah. You can't. You can't undo this. You can't. You cannot. Because whatever you think it is, it doesn't have what it's supposed to have out front, does it? It's supposed to have some kind of x squared in it. Don't. So I can't anti-differentiate this currently. Right? What Calc 2 starts off with is learning more and more methods to try to handle more and more intervals. Right? Integration is inherently more difficult because I'm trying to undo stuff. Algebra is difficult because you're going backwards. Everything is backwards when you do word problems, right? The guy doesn't know how much money he put in the bank. The hell? We're going to work backwards and figure out how much money this idiot put in the bank, right? All right. So yeah, so in 1A and 1B, I just decided to leave a 2 out for some reason. 2 I was having, or 1A and 1C, yeah. I didn't like the 2s. Let's see, 1B looks fine. Yep, 1B looks fine. Cool. Just remember, what's the derivative of natural log of x? Right? But what's the derivative of natural log of the absolute value of x? That actually is going to be the same thing as 1 over x, yeah. Believe it or not. I know, I don't blame you if you don't believe me, but it's true. So the more complete picture, and again, we talked about this a little bit. Here's the natural log of x, right? But what does 1 over x look like? 1 over x looks like this. It exists on both sides. Oh shit. So if I let natural log do this, what's the slope here always? Negative. See that? It matches with that, right? So natural log of the absolute value of x exists on both sides, just like 1 over x exists on both sides of 0. Neither one exists at 0, but they both exist on both sides of 0. So the official antiderivative of 1 over x is natural log of the absolute value of x, just to cover your ass, because you don't know what x is. So maybe.
So we put ln of x and we still get it wrong?
I think for right now, I'd probably just put a note,
Okay.
but for later, you get it wrong. But I'm going to let it sink in a little bit. That's a weird function, but it's really just matching the domain of one function with the other. That's one kind of broader way to look at this.
Can we do 215? Yeah, 215. Test.
Oh, number 2 and number 58. Okay. Okay. Yeah, that one is a particularly yummy one. Particularly. And again, to me, it's whoever your pre-calc teacher was. If you're having a lot of trouble setting this up, you should go slap them in the face, because they did not do enough with you on handling multivariable problems. And these start off as multivariable. We just are starting to get used to the fact that you can get rid of a variable by substituting it for it, right? So 58, a metal storage tank with volume V. So they tell me the volume is V. Yay.
No way.
So too bad for me, there's no numbers there. Oh well. And what is the volume of, what is this? Oh yeah, so let's draw this. It's a metal storage tank cylinder with a hemisphere on top, like a little, one of those little push open trash cans, right? So it looks like this.
That's amazing.
Yeah, I know. So if you want to make it more real life, you can have a little push open panel. Now do you see what I'm talking about? Push it open, throw something in there.
Is it gonna be like a segment? No? Or a circle? Like
It's a hemisphere, yeah. It's a half sphere,
half sphere.
right? So what is the volume? What's the volume of a cylinder? You guys remember? Circle.
R H.
Yeah, so if I call this R and I call this H, then I get pi R squared H. That's the volume of the cylinder piece. What's the volume of a sphere? And I'm going to cut it in half, because we got half a sphere.
2/3 pi R squared H.
Yeah, so this will be, it's normally 4/3 pi R cubed, but now it's going to be 2/3 pi R cubed, because that's half of it. So I'm not going to assume you know volume formulas. I'll give you the formula for the volume. You guys with me so far? Alright, so to put together the complete volume I'm working with, it's the cylinder volume plus the hemisphere volume. Right? So my volume, which is V, is 2. You can do a 2, Jeff. No, 2s. I just don't like 2s. I don't know. I shouldn't like 3s because I can't make them. Plus pi r squared h. Alright, so this is what they tell me. That the volume is V. Ooh, wow. Then they asked me what dimensions will require the least amount of metal. So how do I construct this thing? What kind of surfaces do I need? Think about it. Come on. What kind of surfaces do I need? Construct this thing. If you pick it up, you don't want all the garbage to fall out. So you need a bottom to this bad boy. What's the area of the bottom? That's crazy. So now I'm going to put together my surface area. So the bottom is pi r squared. I don't have a top to the cylinder because I'm going to put the hemisphere on top of it. I don't want another top there so when people throw trash in, it just bounces off. No, I need that open. Alright. Plus, I don't know if you guys remember the idea, if I open this up. Yeah, exactly. If I open the cylinder up, the sides of the cylinder up, stretch it open, then this is going to be 2 pi r. And this is going to be h. So what's the area?
2 pi r.
2 pi r h. Craziness. Plus the surface area of a sphere is weird, but let me see. The volume of a sphere is 4/3 pi r cubed. What's the derivative of this?
1/4.
That's the surface area of a sphere. And we talked a little bit about that, like putting tape over the sphere and doing all that kind of stuff. I don't know if you guys remember that. That to me is just kick-ass cool. Anyway, the area of a circle is pi r squared. What's the circumference? Well, it's the derivative of that, 2 pi r, which is the circumference. And that's a 2D version of this 3D result. And how much of the sphere do I have? Half of it, so it's going to be 2 pi r squared. Alright, let me stop there for a second. So what am I constructing now? I've constructed the formula for what they told me. Now I need a formula for what they asked me. This is starting to feel familiar, very formulaic. They're going to tell you something so that you can use it to replace one of the variables with some expression. They're going to ask you something, which makes sense, or else what's the point of it being a question in the book? They ask me to minimize or maximize something, or so I want to set up the equation for that. This has got r's and h's in it. Well, that sucks. I can do a little bit here. What can I do here? I can just put those together, right? 3 pi r squared plus 2 pi r h. I'm not going to factor because then all of a sudden I need product rule. Right? Screw that. But what do I want to get rid of? Or what variable is easiest to solve for up there? Hell yes, h. Try to solve for r. No. No. So, how do you solve for h? Let me stop for a second. You guys, what's most important when we do a problem is to understand why I did what I did, or what makes me do the steps I do. Is this a standard problem making trash cans? For some people, yes. For calculus, no. It's just a problem that we could do this shit with. Are you ever going to see another problem like this? Probably not. So you're like, well, what's the point? Well, the point is, this is one example of getting used to how to attack it with the steps. They tell you something. Write the formula for what they tell you. They ask you something. Write the formula for what they ask you. That sounds like a simple step, but that involves drawing a picture, putting some variables on that bad boy, figuring out what the relationships are. And they're not always the same. They're very different. Right? So there's as a student, you just want me to tell you, now you solve for r, and then no, I can't do that, because it depends. Is it an equilateral triangle inside of a circle? Right? I mean, that's going to act differently than with a trapezoid that's around a square. It's going to be different. So, too bad. Sorry, you can't generalize these things, but you can generalize the approach. I need an equation for this because that's what they told me. I need an equation for this because that's what they asked me. That at least motivates you to realize what you have to work towards, right? You don't feel so vague, floating. Do calculus to something. Oh shit.
Can I also ask you?
Sure.
The radius would be the same radius?
Yes, because this bad boy is sitting on top. So the radius, whatever the r is also the radius of the hemisphere. Thank God. This is not a big. It's not like big helmet from Spaceballs, right? No, it's not this. No.
Because
it's
sometimes
right on there.
Radius might be different for you.
Oh, that would so desperately suck. So no, it's not. So thankfully, it's a hemisphere that's sitting right, and it fits perfectly onto the cylinder. And they don't say that. And the fact that they don't say that tells me that's what I'm going to assume. Because if they meant it differently, they'd have to say, oh, the radius of the spherical part is different. And they don't.
Okay.
Good. Okay. So where am I at right now? What have I got to do right now? What's this function, what I'm going to do with this function eventually? This one. I want to do what with this? You're thinking backwards. Immediately I'm going to solve this one for h and plug it in here because this is the function that I want to minimize, right? I want to minimize the amount of material I need to make this because that's going to minimize my cost. Right? So if I solve this for h, I get v minus 2/3 pi r cubed over pi r squared. Is that cool? Subtract that, divide by pi r squared to get h by itself. And I think I simplified that because now I got to throw that whole thing in right there. I think from there you can kind of follow. Once I get this in terms of r, I can attack it with derivatives and then set it equal to 0, right? Get my critical numbers.
Okay.
And that's the rest of that problem on the answer key. Oh yeah, I like how I did ... If you do the work, it becomes that. It's kind of gross. Where am I at? 3b? Okay, all right. Any more questions on that? It's all about constructing an equation for what they ask me to minimize or maximize. That's the main goal of any of these optimization problems. If I say minimize the area for a given volume, or I need an area formula relating all this shit he told me so I can attack it with derivatives. That's your goal. That's your motivation. That's what you're trying to make happen. Kill on fire. No, derivatives. Kill it with derivatives.
I think derivatives are also killing me.
Oh, it's a mutual killing. Alright, so on this problem, I'm going to tell you right now, I'm going to ask you for a rough sketch to begin with. You're going to have a graphing calculator so you can do it in there, and some of you guys just can't hide the fact that you're just taking it right in a graphing calculator. So yours will be easy to grade. You should be able to give me a rough sketch of this without using a calculator at all. So do it. Try it. And this is not a completely. Don't do this. No. You gotta put some kind of scale on there, or else you don't know where these are, right? So if you can plot some scale on top of that, maybe it'll work out. But you want to be a little careful because you saw how if you're a little bit too far away from your guess is too bad, the whole thing goes to shit. So you want a decent first guess. So don't make your scale dependent on pi, because for the parabola, that's going to suck. You should be able to estimate what pi over 2 is, right? With half of pi is about 1.5. Good for a rough sketch, right? Say pi is 3. Good for a rough sketch. So sine, of course, is 0 there. Where's it hit 1? Sine likes y, and where's it all y? At what angle? Oh man. Alright, let's convert this to trig. So I'm trying to graph sine. Where's sine hit 1? No, sine of 0 is 0. Sine, so the way you should have been taught is sine likes y. So if I'm at an angle, I'm catching up to you. If I'm at an angle that is all on the y-axis, then sine is the biggest it could be. So that's 90 degrees. I'm all on the y-axis then, right? If I'm at 0 degrees, that's where cosine's biggest, because cosine likes x. And that's why in the middle there are mixtures of x and y. So that's why sine slowly grows and cosine slowly shrinks until it gets to be all sine. And then there are negatives and stuff over there. Who cares? If you know the first quadrant, you know everything. So it hits 1 at pi over 2, which we said was roughly 1.5. Right? Get over there. And then at 3, it's going to hit...
0.
Yeah, that'll be pi, right? So at pi, it's going to hit 0. So the same thing back here. It's going to hit -1 at -1.5, and then it's going to hit there. So there's my sine, my rough sine. And see, I know my parabola is only going to live in here, so I don't have to take sine out too far. My parabola, x squared minus 4, it has x-intercepts of what? 2 and -2. And it's got a y-intercept of -4, and that's plenty good enough for a rough sketch of my parabola. So now a good first guess. I used 2.2, and I can't remember down there, 1 point something, -1 point. What did I use? -1.2. My sketch was really sucky. Here it looks more like I'd use what? Well, it's up to you. I don't know. Yeah, -1.6, 1.5, something like that, right? I used -1.2. I think it came out to be. Let's see, where is it? Oh, here it is. I'm looking at the wrong one. Yeah, it came out to be -1.735, blah, blah, blah. These are decently nice functions, though, so I don't have to be crazy close. But you do want to be closer than, just going, well, let's try 3. So you got to have some idea of what you're going to try. So I want to find both roots. So if I want to try to find this root, I'm going to say x1 is -1.6. That's my first guess. Or 1.7, or 1.3, or whatever that, 1.5. Negative, whatever you see on your rough sketch. Now, of course, some of you guys are like, I'm just going to plug and find the intersection and know ahead of time what the roots are. Well, whatever, I can't stop you from doing that shit. Right? But don't do that. Come on. Or else you're going to force me to give you something with no calculator on it. Yeah, it's too bad. So how do I set this up? The formula I'm going to give you. So you remember what it was?
Extend, f of extend, f prime, extend.
Yeah, it's not hard to remember, but I'll give it to you anyway, so you don't have to get all anxious.
I was getting anxious.
So what's this look like using the function that I'm given? In fact, what would f of x be? What do I have to do to this first? Because Newton's method is designed to find roots. The reason I draw this before I solve for make it 0 is because it's easier to graph these two functions and then find where they meet. But to find f of x, I have to get this to equal 0. So I think I chose to go this way. You can certainly choose to subtract sine. It doesn't matter. Both ways are going to come out the same. I think that's the way I chose. You guys with me on this? Newton's method is built to find roots. So I need something equal to 0 for it to work. The answers to this are the same as the answers to this. Duh, right? They're the same freaking equation. So that's why everything I'm doing is legal. But for this method to work, I have to get it equal to 0. So this is my f of x right there. So what's f prime? Minus 2x. I like it. Good. So then this is going to look like a and s Thanks, dude. Minus f of ANS.
I'm 12.
Pretty much, but it's okay. I'm the one who said something about it, so I guess I'm worse. Over cosine. Hopefully, your ANS is not too big for the cosine. Oh, Jeff, come on. It's so not professional. I don't care. That's why I teach college now. I can say that kind of shit. And I can say shit. So this is, do you understand what's going on here? This is how I want to build it for myself so I know exactly how to put it into the computer, into the calculator, right? You first want to get at a starting point. So you put negative 1.6 in. Then you write this whole thing in your calculator. Now, of course, you want to do this so that it knows what the top and the bottom is. And then you enter until it stops changing out to however many places I say, right?
And you give us specific how many decimal points you want.
Yeah, this one said 4, and I went too far on there. I mean, you just keep going until the first. If I say the first 4, you just keep going until the first 4 stop changing. Or actually, you keep going until the 5th one stops changing, so you know that the 4th one won't change anymore. I don't know if that makes sense. Okay. So if I wanted to go out until it's right to the 8th decimal place, then you're going to have to go a little farther.
So it'd be like,
However big your calculator can show. Are you guys okay with this? A little bit?
And then, like you said, as soon as we get our answer, we just keep hitting enter, and then
Yeah, you put this in, enter. Build this, enter. Because it starts, it puts this in, the first time you hit enter after putting this in. Then it's got the x2, right? This will be x2. And then you hit enter again, now this is going to be this. It's going to refine that, and then it's going to refine that, and then it's going to refine that.
And since we're algebra here, would you say we have to, like, how far do we have to go in our work, and then?
Your work for this is showing me this.
Okay.
And then just listing what you get.
Okay.
That's your work.
Okay.
Yeah. Please, dear God, don't think that you have to actually do this and put the decimal here. And then, no. Your work is this. And then just copy what your calculator has in a little table, just like it did there. Yeah. So that's if I start with, where did it go? Negative 1.6. And then the other guess I had was 2.2, right? So then I would put 2.2, and then I would just do this. If you're smart, you'll do negative 1.6, build this in, enter. Then you'll put 2.2, enter, and then just go up to where this is and do it again. Blah, 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 blah. You don't have to rebuild this whole thing. You've got it into the calculator already. So the more comfortable you are with the calculator, the easier this thing is. Okay, maybe.
So you keep
So-
pressing enter until the answer repeats.
Until it stops changing. Like, do you see how my answer says negative 1.7893?
Yeah.
And then it's negative 1.7364? So the 893 became 364, and then it's negative 1.73598. So that's still changed in the first 4 places. And then the next one, the first 4 places are the same. Actually, the first 5 places are the same. So that's why I know I can stop. You keep going until the first however many places I ask you to go out to, they don't change.
so if you ask for the 4th, you should keep going until the 4th number stops.
And like I said earlier, technically you go until the 5th doesn't change, because then you know for sure that the first 4 won't change anymore, because it's homing in. So if the first 4 don't change, if you keep going, then it's like, but now the first 10 don't change, and now the first 20 don't change. I'm like, I don't want that much. Good Lord.
first 100 don't change.
If your guess is bad, what's going to happen, do you
If
think?
you guess that for,
Keep going.
It could go like 1.4, 20, 1800, 3 billion. That's a sign that your first guess was bad, right? I don't want you to just copy that down and keep going. That means that, just like we saw visually, I showed you, the tangent line took you off somewhere where the function is just doing something else entirely. So you're...
so is negative 1.5 at the horizontal tangent line of sine?
Do what now?
Is it?
Oh, does it matter for this problem? But yeah, negative 1.57 and 1, pi over 2 are the horizontal tangent lines, of course, because that's where
So
the sine is maximum.
So a negative 1.5 gives that guess for find your first root.
Exactly, good, yeah. Negative 1.5 itself would be a bad guess. I'm glad you said that, because that would take, negative 1.5 would be a bad guess for different reasons, because it would be on this side, it would actually take you off this way, and then you might be finding this root. Well, and let me come back even one more time. Neither one of these functions is this function. They're both a part of this function, right? So I don't know where this function's horizontal tangent lines are. Do you see what I'm saying? So that should be something, since I don't know where they are, I have to pay attention to my table and what it's telling me. I should get really strange results if I've chosen poorly.
Okay.
Yeah. So in reality, normally we don't know where the tangent lines, the horizontal tangent lines are for the function I'm looking at necessarily, unless you stop and you can do the work and find out where they are, right? Yes. Oh, good. So we got to do 5. What time is it? Okay. Thank you. Because 5 is the one that I don't have on the answer key. All right. So 5 is the one that I'm going to basically give it to you just like this. So I'm going to give you the form of the limiting sums.